All right. So this is exciting. Glad to have this first call. Um, yeah, as I noted, and this is kind of like coming together, bootstrapping this first call, but really the plan will be to migrate this to a public call on the protocol calendar moving forward. We just wanted to make sure that we can right size the meeting, align on some objectives and artifacts. Excuse me. And so I went through and, pardon me, uh, pulled together a bunch of different resources. This is all in the document that's attached to the invite. So there's some resources here, happy to add to it, trying to document like who's going to be contributing to this effort. And really the goal is to use this call to first talk about the different proposals that were put out by the ZEAM team and the ReamLabs team, discuss any takeaways from Beam Day, and then hopefully try to converge on a shared work plan that we want to then socialize and have be the framework for what we do moving forward. I'm going to pause for a moment, clear my throat. Okay. Um, so if maybe Gajender or if one of you wants to like kind of start us off by walking us through your proposal, I can pull it up and share my screen and talk through it.
Yep, sounds good. Maybe Zeam can go, I guess. Yeah.
Please go ahead.
All right. So you already clicked on the meme. So the point is, so meme is the main thing. This is a meme-led development. And the meme says that we will not work in silos. We will collab. And DevNet is the right way to collab, as we have already seen in the Beacon development roadmap, how various teams comes together and they collab on the spec. They figure out, they try to run, they test, the tests are released on the spec. Everyone tries to make sure that they can pass the test, and then they try to interop where other issues are discovered, and the spec gets simplified. And this is what we are hoping from this particular series. And the aim of this series is to accelerate the post-quantum signature schemes that Beam/Lean consensus is trying to basically position as the end game for Ethereum consensus, because we know that quantum computers, the development of that has really accelerated, and it's basically high time to iterate and to implement and to make and to prove that we have a scheme that works. And so that whether it whether it's implemented as a beam hard fork, or it's just absorbed by the normal beacon research and development, it's a win-win for us in both of the scenarios. So again, the aim of this DevNet series that we are here for and is to prove that the PQ, the post-quantum signatures work, to achieve interop and a spec consensus, to accelerate research, and to provide basically a test bed for P2P research that we think will be required in sort of the larger signatures that we have, and the kind of validator set that we are trying to target. So, and then the bonus outcomes would be to sort of build the tools around this. And what we want is that we want to set a target for ourselves, which is like, okay, we have a stable month-long running DevNet by the next Beam Day. and then we work backwards from over there and figure out the time, the milestones that we need to cover to make sure that happens. So basically, this is a very simple DevNet series as such, because we are only targeting that the post quantum signatures and to begin with, and then on a later stage we should also be targeting aggregation of those signatures. So Will, if you can scroll down. So the scheme, so there have been many papers published on the scheme, and I think there will be another paper published on the actual parameters, which might be 64 hash chains with a chain length of 8. Basically, the aim is to minimize the signature generation or verification hashes, so that the prover and the verification when we do for signature aggregation, that is quite easy. And the lifetime of, so these are one-time signatures, and then they are sort of they are created in a multi they are so XMS based scheme is applied on top of that to sort of make sure that you can sign multiple times. And then there is the question of lifetime of the signature. And for most of the series of this DevNet series, we think that we'll have a low lifetime, because we want to iterate fast, and there is no point trying to have a tool which takes quite a large amount of time to generate the signatures, because that is something I think is not contentious, that we can generate the signatures for a longer lifetime. So I think that maybe we should have a short lifetime to begin with, and eventually go for a month-long lifetime. And if we feel that it's imperative that we show that, okay, we can even work with signatures for like 500 years lifetime, we might go for that. And again, as for the aggregation, we are starting off with unaggregated, and we'll add them as and when aggregation library will be ready. On terms of blockchain, what ZEAM is proposing is a minimum viable blockchain, which basically means that there should be parent-child linkages, and it's quite easy actually. It's not really difficult to track latest block header in the state and sort of do that validation in the state transition function. So I think it's basically, it's very low hanging fruit that we should just have it. And with regard to justification and finalization, we are proposing Mini 3SF variant that we have implemented, because I'm saying the ZEAM variant over here because we did some changes to make sure that there is some special processing for the first block to make sure that the genesis is slot 0 itself. So I mean, all these are very slight modifications, and then there is translation of the various structures into SSZ containers. So it's not really difficult to map those things, and I think it doesn't really matter how we do that. So I don't think that it's going to be contentious in terms of how we map Mini 3SF onto our implementations. So for networking, I think there needs to be a block by root request response apart from block and attestation gossip. So we might just start with the gossips of 1.2 and then iterate on gossip strategies. But I think we also need block by root, if not block by range, because block by root, for example, you got a gossip, but you missed the parent block, and then it will sort of become a deadlock scenario if you don't have block by root. So if you have block by root, basically, as long as you are not syncing, from Genesis on a very long chain, block by root should be sufficient to sort of handle any syncing scenarios that we might encounter, and we will encounter it because there is going to be variability and some sort of error misses and all that in particular in the devnets, especially when we are starting something new. So this is a particular thing that I think we should require. Regarding using Quick, most likely we are okay with Quick because we will be either using Rust libp2p or we'll be using Zig libp2p bindings over some C library, but this sort of remains to be seen, and we are sort of trying to figure this out. So without doing an actual experiment with Rust libp2p library integration, I will not try to, I don't want to commit over this, but I think we can figure this out. It doesn't, we will be able to figure this out whether we can do it over Quick or we'll go with the Amox. And other basic handshake mechanisms we might require for networking, like ping, metadata, status. All of these are quite simple in our viewpoint and should be okay to implement as a very basic needs of our client. And for uh, encoding for gossip and for request response, we will basically go with snappy and snappy frames, same as what is done on Beacon Chain. For other basic functionality, I think that we require is checkpoint sync from the last finalized, because we don't really care to support checkpoint sync from any other checkpoint, and last finalized is good enough because then we have block by root that can help us sync post post the finalized. So once we have checkpoint sync from last finalized, and then we have block by root request response, then we are basically sort of sorted in terms of any syncing issues that we might encounter. With regard to slot duration, I don't, we are recommending to go with 4 seconds because this is what we want to target eventually. And I don't basically see a point where we should start with 12 seconds. We don't have any of the baggage that Beacon Chain has. And with respect to that, we don't even have aggregation to start off with. And signature, we estimate that generating a signature and its verification could be very fast. So with regard to that, I don't see a reason to have a longer slot time. And we are again recommending SSZ with Poseidon 2 for encoding the consensus objects. I think that is sort of a no-brainer / non-contentious proposal, and most likely it has a widespread support. Coming to the success criteria that we basically propose a 98 for any iteration. We propose a 98% average attestation correctness over DevNet lifetime. So whether the DevNet lifetime is 10 days or it's a month. So we propose that once we have this average attestation correctness, we basically say that, okay, this particular iteration of the spec works and we can now try to scale it up. And for example, starting off with 10,000 validators and 10xing on each of the iteration and going up to 1 million validators. And if we can also basically inject adversarial actors that generate bash signatures or try to generate signature collisions, I think that would be a bonus step. Censoring aggregators, or since aggregation is a sort of a ZK proof, ZK verification. So so I'm not sure whether this is possible or not, but because the instruction set would be quite limited. But can we have signature killers in terms of prover killers? This is something I think food for thought. And I'm not sure how much of this is the concern, but I'm just throwing it out so that everything is covered. So these are so these are the adversarial actors that we think that we should think of surviving in any particular DevNet iteration, and it is a bonus thing. So we don't need to begin with this. We can just add it at later mature stages of the DevNet. But if somebody has to work on sort of making these adversarial actors, they can start thinking about it. For us, the next steps would be to finalize the signature params. Most likely, they are going to be what we have proposed and what Ream has also proposed. So then what it really means is that having the releases of the signature libraries with those parameters, and then having the binding / API into that. And once we have that, then basically we can sort of start experimenting at the client level. And in the meantime, we can also generate the spec for beam chain / lean consensus of the basic functionality that we want in terms of state transition function and in terms of fork choice. Because once we have these two locked down, basically we have locked down the more basic functionality of how we are expecting this DevNet chain to behave. And then I think we will need some iterations over coming to consensus over basic networking for different points that I raised. But again, I don't see it as a major contentious issue, so I assume that we will reach consensus over there very fast as well. And then going by how the DevNet is done on Beacon chain, we should have sort of a first iteration spec, and then we can, on the basis of that, we can have ETA and implementation ETA. And basically, if we have all these things, what we basically then need is a Genesis generator, which basically takes number of validators and lifetime and sort of generates the Genesis state as well as public private key for the validators. So this basically sorts of covers various points that we need to make sure that we can kickstart such a series. Yeah. And I think, yeah, that sort of covers most of the points from ZEAM.
Fantastic. Fantastic. Do you want to go through the Ream one and then kind of go over any overall questions, or do people want to pause here and ask questions?
Yeah, I think it would be nice to do a Q&A when like things are still fresh. I do have a couple of questions myself, actually. Maybe I'll
Shoot.
start with the questions.
Yeah.
Sure.
So I guess my personal view first, because we haven't really talked in the team based on ZEAM's point of view yet. So this is my personal questions and opinions. I think 3SF is definitely interesting. I think we discussed that in the team, but we are not so sure how. Like we have the Rust implementation based out of Vitalik's prototype, but that's basically without any like networking. It's only simulating in one process, right? So I guess like at least my concern is I'm not so sure how much effort that would be to actually turn that into an actual client implementation that you can run in a network setting. So that's one. The second thing is I think we didn't put down anything about like signature killers. I think like introducing bad signatures would be interesting too in that sense. I guess it's probably not difficult as well to introduce a few clients that randomly produce like invalid signature from time to time. So those are the two things. I do have some questions. So first thing is the 10,000 validators. So I guess like the estimate of like current actual nodes right now on the Ethereum mainnet is around 8,000. So I wonder whether like 10,000 validators might be a stretch, and also I guess like the effort to to set up like a 10,000 validator network, that could be quite challenging or not trivial to simulate.
Right. So I'll sort of go one by one. And so first talking about Mini 3SF, I think in any case, you will sort of need to generate an attestation and vote. So doing it over networking is not really difficult in the sense that you will basically serialize the data and just publish it, and the others will get it deserialized and sort of import it into your fork choice. Uh, I don't see any challenge with regard to that. And when you are just packing it in a block, again, it's basically SSD that does all the magic. So I don't actually see any challenge over there, but we can definitely talk about this offline, of any concerns that you think can come up. From our estimation, from our development that we did, we have sort of integrated. It's not really a standalone library with us. We integrated it as part of the ZEAM client, and so the thing that you will deviate most will be when you will try to do the fork choice of your blocks, right? Because the way, for example, Vitalik's implementation is not the way how fork choice is, for example, implemented in the beacon chain, but it's sort of essentially the same thing. You are trying to have a view of the latest votes, and then you are just applying it, right? So you are making the changes, you are removing the weight of the previous votes and then applying a new vote. So you have sort of a vote tracker that says that, okay, this particular validator voted at this particular block previously, and now you have a new latest vote coming in. So you will just apply those changes when, for example, you are trying to find a new head on a new slot. So with regard to that, I think you can look at our implementation, and basically, we can discuss it and sort of figure this out together. So I don't see any issue. I think we will be able to figure it out. Second thing was regarding to 10,000 validators. I mean, when I say 10,000 validators, I don't mean 10,000 nodes. What I mean is 10,000 keys, uh, uh, because even if you have 10,000 keys, it will be, for example, your Genesis generator will have to work that hard, and will have to sort of generate all those keys with this particular lifetime. And then you have the votes coming in that will generate traffic on the network. So we will try to see how many nodes we can actually have on the network, and sort of, but in any DevNet, we don't have that many nodes, that is for sure. But maybe this will give us some insight into what is the kind of traffic that is being generated. And going to 1 million validators is again for the same reason. Again, I here mean the keys, because we want to see what is the kind of traffic that will be generated, and how to optimize Gossip Sub to handle it the best, right? So we have so the aim of this signature testnet is, okay, first prove PQ signatures work, and then basically to aid in the research to make these signatures viable at scale uh, for Ethereum. So with regard to that, we will basically need to scale up the validator keys and basically say that, okay, this is how we'll handle the traffic, because we are trying to keep our chain length small. That means the signature size is going to be big, and that basically is a critical difference that we have. And when we have aggregation also thrown into mix, so once we have the basic signatures working without aggregation, we should throw aggregation into the mix as soon as we have the aggregation ready. With regard to signature killers also, I think doing bad signatures is the easy thing, as you have mentioned. But when I was mentioning about signature killers, I was mentioning about aggregation killers. And that is something that I'm not sure whether they can even exist, because the instruction set is quite small over here, that the signature prover will need to generate proof on to sort of aggregate it. But I sort of leave this open question to the cryptography and research teams to answer whether this is actual problem or not. So as of now, I'm not sure. And what was the last thing?
I think that was it. I do
Yeah.
have one more question though, on the attestation correctness. Like, what do you mean by the correctness? Like, is it like all validators receive the attestation and validate correctly, or yeah, what's to calculate that in your mind?
Right. So when, for example, you are voting on beacon chain, right? So you are voting on source,
Okay.
you are voting target, and you are voting on the head, right? So these three things is basically, so if your head is correct, basically, which is what is matching with everyone else, then other things are correct. But it could also be that, for example, your inclusion is also delayed, right? So we have all those parameters where we basically figure out that what is the effectiveness of a particular validator, right, attestation, and that is something that we should take the same target, because that is where that is how the rewards are distributed to the validators, and that is something that is relevant to everyone who wants to stake, and is a benchmark that is quite important. So we will basically define what the correctness is directly, or as it is defined on the beacon chain, and we'll basically sort of track it and figure it out, which having 98% of that correctness means that most of the validators are able to follow the chain and are able to sort of correctly vote onto the chain at the correct time. So this is what it really means, and having 98% correctness means that, okay, it was a successful DevNet. I think with regard to DevNet, we can even say that maybe even 80% average is good enough. But here we want to establish other things that, okay, you can sign it on time, you can aggregate it on time, you can publish it on time, right? So there are so many factors involved, and keeping a high bar as a success criteria will sort of expose various challenges that are underlying in this particular DevNet, and that is what we hope that we will discover, and we'll be able to iterate and fix it.
Excellent. Um, oh, do you want to? Oh, Camille, you have a question?
Yeah, hey everyone. Just also had some thoughts about this proposal. Yeah, I actually I more like idea of having maybe less validators also, because as far as I remember, during Beam Day there were discussions that yeah, we kind of first trying to test just one subnet, even if we're currently doing this without aggregations. If we have, for example, not 10,000 validators, but maybe 1,000 validators, this would kind of give us room for validators to kind of optionally enable aggregation, even if they do not publish their final snarks to the network. Still, it would be great for them to kind of have this and just check like how long it takes for them to generate this aggregation, maybe then share to some public telemetry, like, hey, I generated a snark, this took this period of time, and so on. And if we have like 10,000 validators, this would be kind of complicated to do, because current expected aggregation rate for signatures is around 1,000 signatures per second. And with 10,000 validators, this would take like 10 seconds. So with 4 second slot, this kind of this is too much. So yeah, and it's just in general more easier for us to and yeah, if we have 1,000 validators, this would kind of give us more insights of what we can expect in future if we have subnets. And each subnet would be size of 1,000 validators or so. So yeah, more fan of like having maybe around 1,000 validators for the testnet. Yeah, another thing about Quick would yeah, it's great to have it, but it's kind of would this would give us kind of a more optimistic picture of what we actually have. Quick is better than TCP for many things, for streaming, for kind of delivering messages faster and so on. But yeah, we should kind of maybe optimize for the more pessimistic case. I mean, can expect that if we know like how long our consensus aggregation works, or like distributing signatures among the peers works with TCP, this would kind of give us pessimistic picture, which we can then know that we can optimize using Quick. And if we just go with Quick directly, then it would be harder to kind of estimate what we can expect if we have TCP. So yeah, I would go maybe with TCP first and then try out Quick at some point. Yeah, and yeah, that's just my two points that I want to add. Thanks.
Thanks,
Excellent.
Kamil.
Thanks.
Yeah. So, okay, let me just, yeah. So I think, yeah, it makes sense that, we start off with 1,000 validators so that, we can have a behavior so that what to expect from a particular subnet. So, but yeah, we can again follow the same process of 10xing that again. And for Quick, yeah, I would sort of delegate this to experts like you and other that, what is the best protocol to follow over here for sure. Yeah.
Great. Any other questions on this proposal? If not, you want to walk us through yours
Yep, sure.
or the ReamLabs?
Maybe can I share the screen or
Yeah.
so?
Let's do it.
Okay. Yeah, so for us, this is our view. Basically, well, we treat this view as sort of like a recap of what was discussed in its like entirety during Beam Day. So it contains both like our like opinions, but also the kind of collective opinions from the day as well. And by no means that we think that this document is definitive. We hope like this is like a good starting point to formalize a plan. Happy to happy would be happy if this gets used as a starting template, but also happy if some parts of it get dropped, get edited, and so on. Whatever makes sense the most for the entire collective to move forward with the DevNet. So a few things that I can mention. So first of all, like we think like it's a DevNet. Testnet is probably a bit misleading because I think in order to be a testnet, the features should be more complete. I think this is more of like a one-off, potentially a lot of like throwaway things that we're going to use here for the first DevNet, and so on for the next the subsequent ones. So we think like DevNet is probably the more appropriate name for this. Some of our views include, we favor multiple iterations of incomplete DevNets over waiting to build a complete testnet. We think our first inaugural DevNet is probably more like, apart from like validating PQ signatures, I think it's going to be a lot of like lessons to be learned on, how the lean consensus effort overall can be coordinated, both between the client teams but also like with the researchers. We think the DevNet is probably not intended for public use. Maybe the infrastructure is not even accessible by the public. Um, the features should be limited. I think we prefer to time box it and complete it by end of this year, potentially before DevConnect. So we have some demos to show and also some results that we can show at DevConnect as well. And also in order to kind of like speed this, complete this quickly so that we can take the knowledge and lessons learned from here to do a fresh start in next year. I think the critical questions that we need to answer in the first few calls are the objective of this DevNet. We discussed in the team, and I think like we actually kind of like going to be going over a few steps in order to get this DevNet, like multi-client DevNet up. So I think it's important to be able to answer both to ourselves and also like to the wider community that why this DevNet actually exists and why does it need to be like multi-client interop setting. If most of the stuff that or if all of the stuff that we are going to be doing can be done, under a single client or under a single client DevNet, then that also kind of compromise our legitimacy, I guess, for building this multi-client DevNet as well. The second thing that we need to confirm is the timeline. Again, like I think we can aim for end of this year. And third thing is who needs to be involved. Like right now, we know that ZEAM is fully committed, Ream is fully committed, but we need other key persons as well, namely the PQ signature researchers who hopefully could provide us a sub-spec so we can implement on, and also networking. And also, I guess the big question mark is, are there any other client teams, either new or existing ones, that would like to participate? We should include them as soon as possible so they get involved early. So those are our general views. Then I can go through our detailed plans. Maybe I'll just like glance it over because for the sake of time. We broke down the objectives into primary objectives and secondary. So basically, primary ones are the ones that we should complete. We definitely should complete, and the secondary ones are more of like good to haves. But these are the things that if we are able to include them as part of this DevNet, then we are able to get a lot of benefits out. Primary objectives, proofs, PQ signature viability, validate multi-client interoperability. I think this is also important where each of the subsets, I believe, are being developed in like independent from each other. So this is probably like the first time that we are combining the different subspecs and also combining the two clients. So there's going to be a lot of gaps that hopefully if we can discover within this DevNet, that's going to make our lives for the subsequent DevNets and testnets a lot easier. Validate resource requirements. We talk about this during the Beam Day, that I think we can keep the specs at EIP 7870. So we need to validate that, whether that's feasible or not. And then obviously they identify the specification gaps of what actually are missing in the subspecs for us to actually implement the client. Secondary objectives include establish common metrics. I think we talk a lot about like performance. So for this DevNet, I think being able to kind of come up with like at least like a temporary standards on how do you want to measure things and at what points, and being able to actually share that into a common infrastructure where we can analyze as a whole. That's going to be very important. Again, multi-client coordination protocols. Good to have implementation challenges from just implementing, say, PQ signature, 3SF, key generation, and so on. That's going to be helpful for both our teams right now, new teams, and also existing teams, existing Beacon client teams as well. Reusable testing infrastructure. I'm not so sure if we are going to be able to achieve this, but if we can, or if we can reuse it somehow for the subsequent DevNets, that's going to be useful as well. But these are secondary. Target features, I think we are pretty much on par with ZEAM. 64 hash chain length of 8, max lifetime of 2 to the power 18. I think these are basically the numbers that we kind of like generally agree upon from the Beam Day. Signature aggregation, no signature aggregation, but I think mostly it's because I think the readiness of the aggregation subspecs there. So we should exclude it for now until we see clear subspecs. There are types and containers that we need to agree upon, but I think we can skip this for now. I guess like our view that is different from ZEAM so far is the block that we didn't include the parent root inside the child block here. This is basically based out of the discussion during the Beam Day as well, that I think there's going to be complications with like block syncing and missing blocks, and we have to get all the validators up to speed on that. So avoiding that actually helps a lot of things. For example, not having to implement the APIs for block by root and so on. So this simplifies a lot. Attestation is pretty much the same: slot, attester, index, signature. Serialization and hashing use the SSC that's being used in the Beacon client. I know that there are some improvement proposals to SSC, but for the sake of focusing on like PQ DevNet, I think serialization we should use something that's like already tried and true, which is SSC. Hashing definitely needs to use Poseidon. Consensus. So this is also where we differ, and I think it's also based on the conversation on Beam Day that we haven't really like decided on what consensus. So we think maybe just like go with no consensus, just sign the blocks, propagate it, attest the block, propagate it, and everyone saves their view of the world. That could be enough, and then but the only hard thing is that we don't have a single view of the chain, right? So the only way to actually verify that the chain is progressing correctly and everyone has the same view is probably by this way. It's probably having to go inside each of the validator and actually compare whether they are actually receiving all the attestations and receiving all the blocks, or what is being missed. Networking, quick on IPv4. Thanks for coming for the suggestion. So this is basically based on the assumption that even the Beacon clients are moving to quick right now. So and I think the rate right now is probably around like 68 to 70% that are already supporting quick. And I think TCP YAML is being deprecated soon. So we see no reason to actually try out with TCP at this point. Gossips up. We didn't put down a version before, but my assumption is that we want to go with like V1.1, which is what the Beacon client is actually using. I guess V1.2, I'll need to talk in the team whether that's a lot of work to actually implement. Success criteria. We are a bit I would say like more not as aggressive as ZEAM. So we put down, if we have like 2 client implementations, the network is able to finalize at least 300 blocks. So for 2 clients, that's roughly about like at least like running for 1 hour without like crashing the entire chain. Full block pipeline should finish within 6 seconds. And this is like not a hard criteria. This is basically, once we run the chain, we have all the telemetries, and then we analyze them. All the blocks should be done within 6 seconds. Block proposal, I think this is based on Justin's information in the Beam call. Each block is signed within 1 second, propagate within 1 second, attestation, same thing, 1 second, 1 second. But yeah, the important thing is we are not only measuring just the success of the chain that the chain is proposing and testing. I think the most important thing, potentially most important of all, is actually getting all the metrics for actually running each block and proposing and testing each block. These things are pretty straightforward. These are just like project management stuff that there are actually a few steps before we can actually set up the DevNet itself. For example, the paper, like the subspecs have to be published, reference implementation published. The specs for the DevNet itself has to reach consensus with at least, say 2 clients or more. The clients should already implement the DevNet specs and passing if we are going to have some reference tests, which I think from the lessons learned from Beacon client, having reference tests before we actually initiate the DevNet is very useful to everyone and saves everyone a lot of time. And only after we are able to complete all this, then we actually set up and try out the DevNet. Instrumentation and metrics, I think these are pretty straightforward. Most of them are actually kind of like copy pasted from Beacon client even, but there are some new stuff as well. For example, tracing overall, like the start and the finishing of an operation. For example, key generation, block signing, validation, attestation signing, validation, entire block pipeline. Some logging. Block created, publishes, attested, created, validated, so on. These are going to be, I think, very important to kind of like set a benchmark of like what's the bare minimum of the Beam client that's able to achieve, and also would also help with like troubleshooting things once we get into more complicated features that we introduce to future devnets. Yeah, so I think these are pretty straightforward. There were also some suggestions to actually include like all these like hardware metrics as well, so that we are able to know whether we can, how far are we from saturating the hardware requirements. Timeline. So hopefully, this is pretty aggressive. So by the end of this month, PQ specs, which is already out, reference implementation is already out, so that's good. By the end of August, we should have the DevNet specification itself agreed upon the team. So we have like a bit more than 1 month to work on this. Then for the next 2 months after that, that's client implementation. Hopefully, by end of November or close to end of November, each of the team that are committed to running this DevNet are able to run their own single client DevNet, and by all participating teams. And then by end of the year, end of December, we are able to successfully run the multi-client DevNet. The rest are more of like housekeeping items and some of the rationale, so I probably don't have to go over the details here. So yeah, I think this is our view of the DevNet so far, without incorporating the SEAM's view that's published today. Yeah, Tom.
Yeah, so thanks for the presentation. I have like a question about the specs. So basically, what you are waiting for is the Poseidon spec plus the signature scheme spec. I think that the expectation for both of you is different, maybe because on the REAM side, as you are using Rust right now, you don't need like a spec for Poseidon, for example, because you can just import any Poseidon library like Plonky 3 Poseidon or anything you want. And almost the same thing for the signature scheme, because you can just use the scheme implementation that we have in Rust and just call that, and you don't need basically any specification. I think that on the ZEAM side, things may be different because you are using Zig, and so maybe the core, maybe Poseidon. I think that Ignacio did a Poseidon implementation recently, but maybe you need kind of a spec to be able to use these kind of things. The good news is that we have just started with internally at the EF an effort to push like a minimal spec forward, and have like, we started to set up a repo with a whole like Python framework to have some spec, subspec, and tests. And so we wanted to start with Poseidon plus the signature scheme, so that we could have quite soon, let us say, a working like Poseidon plus signature scheme specification. This should be quite straightforward on our side, because this is basically just us taking the Rust implementation and transforming it into a minimal Python spec. So that are two things that we could have quite soon. I think this is all you need for this DevNet, right? You don't need the aggregation stuff, you don't need the minimal zkVM, and you don't need all of that, correct?
Yep. To start off with our first DevNet, we don't need any of the aggregation bits. And with respect to spec, we definitely might need Poseidon 2 spec, because that is something that will directly integrate with our SSZ hasher. And but for the signature bit, we will also try to just use the Rust library using Zig bindings. So that there, I mean, we don't need the spec right away. So our first focus for the spec would be Poseidon.
Yep. This is my first target also. I will share with you as soon as I have the repo set up and stuff with the testing team internally at ZEF. I will share on the group the repo where I will first try to spec Poseidon. This will be my first work. Yep.
Thomas, one question on the HashSig. Is there a latest version available? I believe the reference implementation that was released a while ago couldn't be used out of the box, at least by us, because the Merkle tree was not, available for exposure. We could always fork it and use it, but we would prefer using one that is, that you from the EF team release, at least for the initial DevNet.
Our official implementation is the one that I just shared. Maybe you should aware of. Yesterday,
this is the one we can use. Yeah.
Yeah.
Okay.
Yesterday we merged the new encoding scheme. Benedict and Dimitri should release an explaining paper soon, hopefully next week, I think. But yesterday we merged a big PR with the new encoding scheme, so things should have changed since maybe the last time that you checked it. But this is definitely the, let's say, for now, the official implementation that we have at ZEF. Yep.
Great. So it seems like Justin, you want to go ahead?
I just wanted to share a few thoughts. The first one is that I'm super happy that all of this coordination is happening organically, and I think almost all of the points can basically be settled among the devs. But I am happy to share some thoughts from the presentation if that's helpful. Okay, great. So one of them is that on the DevNet versus testnet nomenclature, I would agree that DevNet is better because we want to under-promise and over-deliver. And one potential way of thinking about it is to basically start with a proof of concept and then iterate fast on top of that. So there's multiple axes where we can simplify. So one is only having the leaf signatures and no aggregation. The other one that I identified was having a single subnet as opposed to multiple subnets. Yet another one was having no chaining versus having chaining with the parent. And then another one is whether or not we have 3SF. And I guess what we could do is just start with the minimal thing. And if we're going to have these fast iterations, which makes sense, Gajendra was suggesting, every 10 days or so, then we can just incrementally add these features and work our way up. One question that was asked is whether we want a single client or multiple clients, and I think this is a very good question. On the one hand, we want this effort to be neutral, to be open, and I think there's going to be real value to having multiple teams be involved. So, for example, one of the efforts that we want to do is make sure that we have a very friendly APIs and bindings to the cryptographic libraries. And here, having multiple languages will provide different perspectives. I think it's also good to make sure that all of the reference and unit testing infrastructure is friendly. And here we're trying to innovate a little bit. So we have Felipe here on the call, Felipe Selmo from the testing team, who has prepared this spec template, and it would be good to kind of iterate and polish it. It's meant to be all of the best practices kind of condensed into one place, all of the learnings that we've had from both the Beacon chain and from the EELS program. And then I think a good point was made that this is not just purely about de-risking research. In a sense, the research has been de-risked. It's about greasing the wheels from a coordination standpoint. And here, having more than one team, I think, is valuable. Having said that, I think we need to be extremely mindful of not wasting time unnecessarily and developer resources, especially with the existing consensus layer devs that are focused on these short-term strategic objectives. And so like maybe like one possible outcome is that we have, in addition to Ream and ZEAM, one additional existing consensus layer team. And having this third team could be valuable for several reasons. One is that they have a lot of experience and wisdom that they can share with some of the newer teams. They also have like production grade, libraries and like SSZ and networking. So for them, it shouldn't be too much work. And I think it would also be good from a social bridging perspective, right? Because the existing consensus layer teams, they're used to working together. And I think it would be good to avoid the silo between the new teams and the existing teams. And so having at least one existing team could be a good bridge. Another note that I have here is that it's looking like we won't have a Beam Day as I originally envisaged it, but instead it's looking like we might have a whole Beam week in Cambridge. So the idea is to potentially in September have a workshop where some researchers and devs all come together in Cambridge in one of the colleges for a few days, and we try and accelerate as much as possible the post-quantum cryptography testnet and the underlying libraries as well. And we're also considering having a little bit of a Ethereum Foundation architecture sync. So like we have the architecture team and the consensus team, and basically having everyone around the whiteboard to try and come to rough consensus on what we were going to do for the finality gadget and the fork choice rule. So one kind of very recent development is that there's been various innovations at the consensus layer for consensus mechanisms that are extremely low latency. So for example, Alpenglow from Solana. And the question here is, can we incorporate some of these latest ideas so that we have ultra low latency bridging and deposits from sexes and things like that? And one of the potential research directions here is basically to have a little bit of a hybrid construction where we have an ultra fast path, which is a little bit like a safe head confirmation rule that depends that will work like by default almost all of the time, assuming you have a synchronous network, which should be the default, and you have honest majority. And then there's kind of a slower finality gadget that takes a whole 3 rounds of attestations that's kind of trailing. That would be, I guess, my favorite approach. But the consensus team, especially Jan, who's new to the consensus team, is looking into some of these newer designs. And so together, both the post-quantum few days in Cambridge plus the architecture and consensus would form kind of a whole Beam week. Another thing that I have noted is the slot duration. Like I think my personal preference would be to just try and pick a reasonable number. I had this meme of like speed of light slots. It's hard to tell exactly what they will shake out to, but to me, 12 seconds just feels very long, especially that there's proposals to bring it down to 6 seconds. So kind of just from a mindset perspective, I would kind of aim at a little bit more aggressively, something like 4 seconds. And in terms of the signature killers, the good news here is that pretty much everything is constant time, meaning that every signature takes the same amount of hashes to verify, and every aggregate signature as well is the same size and takes the same amount of time to verify. And yeah, the good news is that because you have this recursive aggregation, there's all sorts of attacks and censorship attacks that don't become meaningful. So I'm not too worried about the signature killers, but if someone once you study this, I'd love to chat as well. Now, in terms of like a few other updates that I haven't mentioned yet, one is that and another update is that there's been a ton of progress by Emil and Thomas on the minimal ZK VM for recursion. So there's now a document that kind of explains the key ideas and design of this ZK VM. It's super minimal. It only has 6 opcodes, 2 of which are Poseidon opcodes of different input widths. So it does almost nothing. Like, and 2 of the opcodes are add and multiply, and then there's a jump opcode, and then there's a memory opcode. So only 6 opcodes, super simple, and it looks like it's powerful enough and efficient enough that we could potentially go down that route. You can think of it as being Cairo, but taken to the extreme in terms of minimality. And this bodes well to us being able to formally verify lean sig. Actually, on that point, we now have a suggested branding and terminology for some of those things. So we have Poseidon at the very base, and then we have lean sig, which would be the one-time signature plus XMSS, and then we have WER as a building block, and then on top of that we have lean SNOC, which would be what we're currently calling Whirl Away, but it would be rebranded to lean SNOC. And then on top of that we have the lean ISA, which is the 6 opcode minimal ZK VM. And then on top of the lean ISA, we have lean multisig, which is the multi-signature scheme that kind of wraps everything together. And we have a new lean Ethereum GitHub organization that has been created, and we're hoping to put all of the Python specs, but also the efficient and reference implementation in Rust, which hopefully we'll be able to formally verify at some point.
Awesome. Very exciting. So we're just about at time. It seems like we got a lot accomplished today, going through these proposals, getting a lot of questions answered. In terms of the agenda for the next call, is the goal to just continue to try to arrive at a shared specification for the DevNet, or are there other things that we want to sort of seed the agenda with?
Yeah, I think we could just push this further and try to achieve consensus and sort of figure out whatever unanswered questions we have, so that we can definitely come to consensus by end of this month that what is the first DevNet 1 spec that we are gonna go with.
Yeah, also, if it will be helpful, I can share some insights from simulator. So yeah, I'm doing a lot of experiments right now with different signature sizes, bitrate, like number of aggregators. Yeah, all of that I think should be interesting.
That's great.
On that note, one quick update is that Quadrivium is basically the third client team that has received a grant from the Ethereum Foundation.
Beautiful. And then also, Michael, you're on the call from ProbeLab. I don't know if there's anything that you wanted to say about the ProbeLab role in this process.
I mean, we are currently collaborating a lot in the Pusaka DevNet, pretty much monitoring that each of the client implementations is fulfilling what the spec defines. I guess that we could do similar work ensuring that everything or everyone is on the same page. But yeah, it's still up to define how can we collaborate monitoring all this work.
Okay, great. We'll keep an eye on that.
I think one question that Owa also asked is that do we have any idea, or Jihun asked, is that do we have any idea which is the third team that we are targeting? Because I think it would be good to get them early on into our discussions and sort of get their viewpoints and expert opinions.
Yeah, I don't know. Justin, do you have anyone that you think that we should target or anyone else? Like basically who's going to add value and maybe has the largest team. We're not going to like cannibalize resources from something more timely.
So I don't have a strong opinion, and I also must say that I don't have a strong opinion that there has to be a third team. I believe that Will has started talking to the various existing consensus layer teams to do a temperature check. I mean, I can think of like multiple pros and cons for multiple teams. Like, for example, if I were to pick Lighthouse, one of the pros is that I believe they made a hire specifically for the Beam project. I guess one of the cons is that we already have one of the clients, Ream, that is in Rust, and so we wouldn't learn as much in terms of the cryptographic bindings, for example. Yeah, if I don't know if Ladislas is here, but maybe he could take responsibility for trying to find such a team.
Yeah, I have reached out to a couple of folks, but yeah, I guess generally I would say it's I would like to leave it up to them whether they want to join or not. Like it's not like we can only demonstrate like that we want to move forward, and so it's on them to be in or out in terms of being mindful about the resources they want to spend on this, and of course that we can, like even if after one call or a second call or a third call, that they are at least we keep them informed as good as we can. So and this is a bit on us as coordinators. So yeah, TLDR, I will reach out to them again. I guess we will share this recording here as well, probably also a summary of it, and then collect feedback from them.
Great. Yeah, and then the final thing, the standing call moving forward will be, I just want to make sure I have this correct. It's going to be Wednesdays at 2 p.m. UTC, so this same time, but on Wednesdays. Okay.
Okay.
Imagine you had a question adding a PM repo to the lean Ethereum org?
Yeah, I was just sort of responding to O's comment that where is the best place where we can sort of share documents and sort of collab on plans, publish specs and all that. Yeah.
Yeah, I'll work to have something proposed for the next call on that front. Great. This has been fun. Have a great weekend, everyone.
Thank you.
Thanks. Bye.
Thank you.
Goodbye.
Thanks, guys. Bye.
Thanks, Will.
Thank you.
Thanks, guys.
Thank you, everyone. Bye bye.
You guys.